let's get started. I would like to introduce to you Kaizen's own Vice President of Global Technology, Ram Wissel.
Hi, Sherry. Thank you all for joining very much. And good morning. Today's topic is going to be on the importance of rinsing. In my role at Kaizen, I get to work with a lot of our technical support team and customers talking about their cleaning process. And one of the questions that often comes up is, why has it been said that you are only as clean as your final rinse? And like most people, I enjoy starting my day off with a nice cup of coffee. And the analogy I like to use when talking about rinsing is that if that cup isn't fully rinsed and there's a little bit of soap suds left in the morning, the coffee's not going to taste quite as good. So, making sure that the dishes or your electronic assemblies are fully rinsed is very important. And so, what are some of the risks that are associated with poor rinsing? Well, for that, we've got to think that wash solution contains the cleaning agent, water, and also any of the dissolved contamination, and realize that that's going to change over time. So some of those contaminants can be ionic residues, and we're concerned about those because they really promote the potential for ionic or for dendritic growth and corrosion. Another less talked about material is organic residues. And these are things that can interfere with conformal coating, part marking, adhesion, or subsequent processing steps. The other thing that we sometimes hear about is on complex parts, we may over time have some wash solution weeping out. And it's an indication that the product wasn't fully rinsed during the build. So modern components present a lot of interesting challenges. They're very flush mounted to the board in many cases. They may have some complex connectors. And if we think about water, it has a very high surface tension. So the droplet forms a tall bubble, if you will. So to clean these complex components, cleaning agent companies add surfactants that reduce the surface tension to help them penetrate and get under. But then we have to make sure we can get all that material back out. So effective rinsing really requires two things: good quality water and sufficient exposure time. So what is good quality water? And in this, the IPC really helps us out, because in chapter 10.6 of IPC AC 62A, it states, good quality deionized water is the preferred rinse medium. Water in the 1 to 5 megaohm region will be satisfactory for most operations, and the temperature of the rinse water should be as high as possible, but comparative with the parts in the process. That means you don't really want to rinse with boiling hot water. It needs to be compatible and consistent with the parts and process you're using. So, what is resistivity of water? Well, you make DI water through carbon and ion exchange. In perfect DI water is really 18 megaohms, but it doesn't last very long. And so, on this chart, you can see that, again, sort of the theoretical maximum is 18 megaohms. And what they're saying, the IPC is saying in this 1 to 5 range, you're okay. Now, resistivity is the inverse of conductivity. So if you have a conductivity meter, you can take that reading and do the reciprocal of it. And it can also be related to total dissolved solids at times. So, if you have really pure, highly resistive water, you're going to have very low dissolved solids. If you get spotting on your parts or you're seeing residues, then that generally indicates that your rinse water is not of a high enough quality. So then it becomes, how many rinse cycles or how much time is sufficient? And in an inline washer, you normally have a cascading multi-flow, multi-stage process, which starts with the cleanest water in your final rinse, then it goes back to your primary rinse, and then sometimes into your chemical isolation. When you look at an inline, the rinse zones are typically much longer than the wash section alone. And you may have a variety of nozzles and different flow configurations to make sure you're rinsing your complex parts sufficiently. When we go back and look at a batch style washer, that normally uses the rinse water in a 30-second rinse, and it will have, on the discharge of that rinse water, it will have a resistivity meter that measures the water quality leaving, or a cycle count. And if you're below that 500 K ohm reading, or maybe 750, or less than 6 cycles, it will continue to rerun that cycle again until you pass one of those criteria and go on. So it's a wash, rinse, and repeat sort of process there. So when we think of rinsing progression, again, that when you have the cleaning agent and you're washing, you have a very low surface tension. But as you go through, whether it be the inline or multiple rinse cycles in your batch washer, that water quality is going to get better and better, and you're going to see that the shape of the water or that water droplet gets taller and it's harder to penetrate. So one of the things that we like to look at is contact angle. And so if you take a look and put a drop of water, a bead of water on a bare FR4 surface and measure the contact angle, in this case, it was 79 degrees. We then applied some liquid flux and reflowed it, and you can see a very drastic change in the surface tension or the contact angle of that water. It's down to about 37 degrees. So we know what sort of good looks like. We know what contaminated looks like. So what happens then when we rinse it? And what you can see is if you do partial rinsing, not complete, water close, but it's measured at 64 degrees. We haven't quite gotten back to that 78, 79 that the surface was originally. And so that's a way to tell that even though you might not see a contaminant, that the surface energy is still preventing water from taking that shape of a pure droplet. So another thing that's critical with rinsing is, the wash bath ages and more contamination gets into the cleaning agent or the wash solution, it can change a bit. So a test we like to run at Kaizen on any customer bath sample that comes in is what we call a glass slide test. And you take a very clean glass slide and wipe it with IPA, let it dry, and then immerse it into the wash bath solution. Rinse it with DI water for 30 seconds, and then allow it to dry for an hour. And then come back and put a Dine solution on it. And what you see here is the surface energy of glass or water on glass should be about 72 dynes. And so this broad purple band shows that glass slide, is fully rinsed. It's a clean surface. On this side, this is a failing test because that glass has some sort of contamination on there. You didn't see any visual spots, but the Dine solution behaved very differently. So you can tell that slide is not as clean as the one on the left. So in summary here, maintaining high quality DI water is essential for your reliable cleaning process. Now you're trying to make reliable quality products. Rinsing is very important, just like my coffee cup in the morning. 18 mega ohm water is ideal, but DI water degrades fairly quickly. And so the IPC really recommends, a 1 to 5 mega ohm minimum. Some people may set that limit to 5, and then when that's a trigger point for them to start to go and maintain their water bottles. If you get too much carryover or contamination to your rinse, you may start to see a little bit of foam, and that's going to be an interesting topic in an upcoming tech-to-tech session shortly. And again, incomplete rinsing can be detected by contact angle or a Dines test or ion chromatography. And ion chromatography is an interesting topic, but we could spend a whole hour on just talking about the ins and outs of that alone. So with that, for today's session, I want to thank you for joining and open it up to questions or comments.
Great. Thanks, Ram. If you'd like to discuss this topic further, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.